air if any of them want to break in. So I actually don't have anything I need to present, thank goodness. Chris, you're up first. Sorry to not let you sit down or anything, but if you want to upload your stuff to the wiki page or give it to Peter so we can get it onto the WebEx, then we can get started.
Sure.
Putting the easiest thing is putting it on the wiki page if you remember your password. So what we're going through here, just for people who don't recognize all those entries up there, we have presentations from both the InstaGENI and ExoGENI rack teams updating you on their current status. Please ask questions if you're interested at any point during any of the presentations. This is supposed to be an informal discussion, not a lecture. We have Joel from Cisco, who spoke this morning, who's here to get into more technical information and answer questions if you have them about what's happening with the Cisco GENI rack. We have Rajesh from Dell, who will be doing the same thing for the Dell rack that's currently underway as a joint project with Clemson. We have some Clemson folks in the room too, but they're not presenting on their own. Peter O'Neill will give an overview of GENI use cases. Because there are lots more different ways that GENI can be used now, he's been pulling those all together into a nice brief summary that people can access and get an idea of what they're getting into if they're new to GENI. And if you're old to GENI, you can see what whether you fit into the use case in the way that you think you do. And then Russ Clark from Georgia Tech is going to help with a discussion about peering in GENI and what we think we're doing for SDN peering and what we as a community of campus and regional people and network core providers want to do specifically for GENI peering. So with that, hopefully you can get yours on there. And everybody has 20 minutes, and I will be ruthless about kicking you out. So please, if people don't interrupt you, try to leave a little time for questions at the end. I don't know if that works. I didn't try it. It's not on.
No. Just talk loud. Can you guys hear me? Okay.
Otherwise, you never know whose presentation you're going to get.
Okay. For those of you who don't know me, I'm Chris Heermann, and I work on the ExoGENI project. The PIs involved here are Ilya and Jeff Chase, Ilya Baldwin, both of them. And really, I'll try and channel my inner Ilya here because this is typically his presentation. And you'll probably recognize some of the features. I'm sorry?
Can't you look a little more unhappy?
So without further ado, I'll go ahead and get started. But no, I should give a lot of credit here to both Jonathan and Victor, who do a lot of the work behind the scenes and in terms of system administration work, and then also just configuring and getting work up and running and keeping it in a good state, in a happy state. So just as a quick overview, these are the areas of the cover. We'll talk about what ExoGENI is, give it a description for those of you who don't know and aren't aware what it does. Okay, so that, I believe that's the one at BBN, right?
Yep.
That is an ExoGENI rack. So it's equipped with, I guess there are 10 worker nodes, one head node. That's kind of the meat of the computation piece. There's a storage piece as well. It's an attached 6 terabyte iSCSI drive, and then there's there are two Ethernet switches that kind of keep together connected to other ExoGENI racks as well as other various different pieces of infrastructure as well. Some of the details are there about the equipment. Is this how much time do I have?
You mean left out of the 20 minutes?
It's 20 minutes, okay. So these are some of the details, and the I guess the part that I'm most intimately familiar with is the 8264, which supports both at this point supports in hybrid mode, both OpenFlow and Ethernet. So we'll talk a little bit about that later on. So ExoGENI itself is a collection of off-the-shelf institutional clouds. Okay. Typically, well, I think that in terms of open source software, what is comprises and makes up most of what we do in that part is OpenStack, and then also XCAT. XCAT's used for provisioning. 2 of those 10 worker nodes are used just in bare metal fashion. And once the XCAT's used for OpenStack, provisions the VMs within the other worker nodes. Operators decide how much capacity to allocate to GENI, how much to retain for yourself. And also EC2 interfaces. So when you create a VM, the standard interfaces or standard images in terms of size, large, extra large, small, we use that standard. The GENI interface. I think that's just saying that we can play well with others. And this is a picture that illustrates the very complex and involved ExoGENI rack software. So starting at the bottom and working its way up. There's the testbed substrate, which includes the rack hardware, and then on top of that there's a layer there for control planes and flow visor, and you'll see that's where XCAT and OpenStack live as well. Also we use Nagios for monitoring. And then the ExoGENI layer, the next layer up, there is the test measurement software, the GENI INM, and the API corresponding to that. On top of it, there's the Orca software and Orca handlers, and then also there's foam there as well, which talks to flow visor. And then on top of that is the tool layer, which operates through all the APIs. Any questions at this point?
Hey Chris, is where am I?
I'm sorry, I'm probably not speaking loud enough. No, and the mic's not working.
Yeah, you got it.
What is the alt-G API?
That's a good question. I think I kind of went over that. Maybe Jonathan. You have an idea?
No, I don't know that we use it actually.
Yeah, Jeff.
Alt-G. Well, there's API. There are 2 APIs. One is internally the work uses one area, the aggregates server slice which is actually the server that represents
Okay.
so we use phishing internally, things like that. But there is also another sort of variant. It's the XML RPC API. In some respects similar to AN API. And Dell, in our spec, has a number of other addresses that allow us to access those features from Blues, which is the front end.
And that's implemented in the controller?
What's that?
That's implemented in the controller?
Yeah, it's supported in the XML RPC controller alongside the
Okay. In terms of rack software, the base install includes, I believe it's 6.3, CentOS 6.3 at this point. Yep. And for base. Can you hear me? Does that work?
No.
Nope, it's in orange.
How about now?
Testing.
Okay.
Is that good?
Yeah.
So it should be up here. Okay. Talk. For resource provisioning, there's XCAT, which I talked about. That's used to provision the 2 bare metal nodes. OpenStack, and this also includes the NUCA, which are our own extensions for the VM networking interfaces, and also FlowVisor. There's a little note there about Floodlight. Floodlight is the controller that we use. That's part of the provisioning for within each slice. You had a question?
So for XCAT, what are the typical things that you would provision a metal of your metal host?
Can you repeat the question? Just
Yeah. So the question was, what would you use XCAT for, right? An experiment, perhaps, right? Someone who needs more computational power than what a VM or even a couple VMs could provide. And a good example, I guess, so within these, within one of those nodes, at 2 of the sites that we'll get to later, there's going to be a dedicated 40 gig NIC. Okay, so whatever experiment and application would need that and the full bandwidth associated with it, that would be a good example. I don't have one that I know in particular, but.
No, I understand the need for physical hosts sometime, though. I'm just wondering, for XCAT particularly, is that a software, an API providing some interfaces for specific tuning on that physical host?
You know, Jonathan? Yeah.
XCAT is a cluster deployment technology. If you've ever heard of something like ROCs, which is commonly used in HPC environments, XCAT is analogous to that. It uses APMI to control the bare hardware, and it uses Red Hat RPM-style Anaconda Kickstart to install. It can also do net booting through initramfs.
And it's supported by the vendors.
It's supported by every vendor I've tried, IBM and Dell and Cisco UCS, and I'm sure HP does it too, but I haven't tried it. I don't have the hardware.
In answer to the original question, we also have XCAT the OpenStack orders.
Right. We deploy everything in an ExoGENI rack except for the actual VMs via XCAT.
So you could, in principle, if you've not actually done it, deploy also another process. This is the idea of Robert Sheet. Control, if you have enough programmability, that'll deploy certain processes. Standing it up as an aggregate is the question. But in principle, that's possible.
You have a question?
I just couldn't hear.
It's hard to hear you now.
I didn't say anything.
Okay, there are 10 minutes left, and that's going to be very difficult, so I will selectively go through things here. Of course, in the rack software, that includes the Orca software, and then also foam. We talked about the IPMI and Kickstart. That's used for monitoring. Yes, okay. Vendor support. The equipment, everything that we use is from IBM. There are the ExoGENI racks that we've been contracted to deliver. They are our primary corporate partner. There's Cisco too as well, and they have donated a rack, an ExoGENI rack based on their hardware to NC State, and then also there's West Virginia Net, who we're in the process right now trying to help them. Using the NCSU rack as a reference to bring them up as well. And there's Dell. And Dell we've kind of bringing into the fold now, and we're looking forward to that. So, probably seen this picture before. This is the 10 worker nodes that I talked about. The head node, which maybe there's the management node and the management switch. And I think the key parts really to take away from this is the connectivity. If you look at the upstream connectivity, you'll see that there's option 1 and option 2. Option 2 would be preferred, but I don't think very many people have that capability, and that's, I guess, when we first started doing this, we were using Sherpa, and we had their API as a way to automatically provision dynamic circuits across NLR's FrameNet at that time. Now, Sherpa, I think, can be used to do the same thing on Internet 2's ION or AL2S or something. Advanced Layer 2 Services, yeah. So, but typically, I think option 1 is what you would see, and that's statically provisioned VLANs across that either ION and or FrameNet. So, and that's what we're currently using with FrameNet. ExoGENI status. Okay, so almost behind us right now, we have, there's definitely the RENCI, there's the GPO, VBN racks that are done and complete. FIU's almost done and complete. I think there's something else in one of the acceptance tests that's just lagging behind. UH is very close, it's in testing right now, that's in Houston. And NICTA is in Australia. They're kind of a one-off, they did most of it on their own, but with Jonathan's help. We have 4 racks right now that we've gone ahead and ordered, and that's at least a 2-month process we've figured out from IBM right now. So we're hoping that maybe sometime in the June timeframe we'll have those other 4 up and running. And what's different about the 4 that we're doing now versus the ones we've done up until to this point is that we have a staging location, I believe it's in Rochester, Minnesota, known as the Yellow Zone. And that's where IBM will give us remote access to the racks as they're assembling physically, and then we can load the software, and hopefully when they hit their destination and arrive, they'll be almost in a plug-and-play state. So that would really be nice if we could get to that point. And I talked a little bit about the connectivity. How much more time do we have? 5 minutes, okay. So this is an illustration, kind of a real high-level network diagram showing the different ExoGENI rack locations, including the ones that we just ordered. So this is what our extended test bed, as you can say, what it looks like in this case. So you see the 40 gig NIC that I talked about, right, would be used at 2 locations, one in Starlight, where one of the ExoGENI racks has just been ordered, and then also at DO8 LVL. They prefer to be called OSF, I'm not sure, Open Science Facility maybe? Anyway, they'll have 40 gig connections going to DOE's ANI network test bed. And then there's also going to be the 10 gig connectivities. Something I feel compelled to talk about right now because it's not in here, I don't think, explicitly at least. Each worker node has a Chelsea 10 gig dual port 10 gig NIC card, okay? And I talked about hybrid mode now being supported on the 8264s. So if you look at an Ethernet switch divided into 2 halves, one half would be dedicated for traditional Ethernet, which is really geared more. We support both. We don't discriminate. But since this was developed, previously using just traditional VLANs and quality of service, policing on egress, we probably are more comfortable and would do. Just looking at me, and I'm getting funny expressions here, but the Orca software works well with traditional Ethernet and OpenFlow both. So we'll have connections from the dual port NIC going to one to the traditional Ethernet side, the other one going to the OpenFlow side. So we'll be able to support either one well. But the key thing to say about this is that currently OpenFlow right now does not support quality of service, right? So there's no policing that we can do on egress. And a key part to the framework, and one of the things that we're trying to provide is repeatability in every experiment. Without that capability, at least from the network's perspective, right, we lose sight of a key requirement, I think. So having that hybrid mode capability is very important for us. Since GEC16, okay, there are improvements in stability. I think that's probably a pretty accurate statement. Although the demo yesterday didn't show that. Things are getting more stable. You can now, thanks to Picher, you can now, this is RPM based, Orca itself. When we go to the yellow stage and we go to deploys or put the software on these racks, we'll be able to do this hopefully just based on RPMs. Yes?
We got rid of Tomcat.
Yeah. Modifying a slice and extending a slice. So this, if you're familiar with flukes and doing this, it's a lot more intuitive, I think, now. You approve both procedures and documentation. There's a lot of documentation. You keep writing documentation. I keep to write more documentation. And acceptance testing. I think we're just about, like I said, almost done with University of Houston and FIU. Might be behind us at this point. But this is actually a very helpful. Peakline is a new, it's a command line tool that Ilya put together, basically that displaces the old web-based monitoring tool that we had for Orca, and it allows more for an interactive capability to find out what the status is of your slice. So this is what's coming. Expected overflow from, this is the hybrid mode. We have begun to test that. We'll do some enhancements that include new handlers for the hybrid mode. There's Cisco hardware integration. One of the things that, in terms of what we've done with Cisco so far at this point, is we're able to do intra-rack slices right now. Intra-rack slices and being able to work with other ExoGENI racks is still on the roadmap, and that includes developing some handlers specifically for their hardware. ABAC is important. ABAC authorization, that's on the roadmap as well. How am I doing?
That's it. But people can download these slides and look at them and ask you more questions.
Fair enough. Okay. All right. Sorry.
Rick.
While these speakers are changing, I have a comment. There was a mention of connecting to the ANI. The ANI has been converted in production. The testbed remainder is not ANI, which was ARRA. So the new term is ESNet 100 gig testbed. Shouldn't use ANI. I've heard the lecture. I'm passing it on.
Can you give it to Peter so that other people can see it?
Yeah.
So I don't need this?
So if you came in after the beginning and you're a presenter, please make sure to put your slides on the wiki if you can, or else give them to Peter so that he can get them on the WebEx for people who are participating remotely. How many people do we have here who are interested in ExoGENI or have ExoGENI already? Oh, Mark, what are you going to do with it? Okay. Okay, in the interest of time, why don't we just let him use his laptop and we'll catch up later.
We're ready.
I
can't because the WebEx is up there. And if there wasn't anybody except the user.
How many we're going to use?
I can't tell. I don't know for sure that there's any others, but I told them
Yeah.
it would be there, so.
Can everybody hear me? All right, can everybody hear me?
Yeah.
Can all of you folks on Webland hear me? In the silence lies consent, they can. All right, so this talks about the InstaGENI initiative. This is, for those of you who have been to Racks and Campuses sessions before, there's a fair amount of repeated material because we started out with perfection, and therefore why do we need to improve? Oh well. Well, it was worth a try. Okay, so this was specifically designed for Chip and Heidi and Mark to deploy all over the place. There were supposed to be 2012 deployments, 24 and 2013. By the end of 2013, we will make this schedule, and I'll go into the schedule and where we are in a little bit. The aggregate managers remain ProtoGENI and Foam for managers control frameworks. Rob is doing Ricci is doing ProtoGENI. Nick Baston is doing Foam. Nick is hiding. Oh, I see him. Thank you, Nick. And this will boot to a ProtoGENI instance with an OpenFlow switch. So for those of you who haven't been at this talk before, when you get onto a ProtoGENI rack, what you are looking at is a baby EmuLab. When you are looking at a network of ProtoGENI racks, what you are looking at is a distributed EmuLab cluster. And in fact, we're going to go 32 times approximately 80. By the time all this gets done, there's going to be on the order of 2,500 ProtoGENI cores across the United States. So in the aggregate, this is going to look pretty much like a distributed EmuLab. But it does more than that because because it's designed for Planet Lab Federation. What we're going to be able to do is instantiate, and in fact can do now, right, Andy? Instantiate Planet Lab nodes on the slice themselves. The Planet Lab IDs are pre-allocated, so it comes up provided with boot. These things wake up. They say, "Hey, we're an InstaGENI Planet Lab node." They federate with InstaGENI Planet Lab Central, which Andy McGeer and Larry Peterson are standing up, and then you'll be able to put these things on Planet Lab. And they're designed for expandability. Now, in part, we can all be honest here. I wanted a lot of, there was a fixed amount of money. We wanted a lot of these things rather than a few of these things. If you want a lot and you don't have a lot of money, what this means is that there's going to be, is that they're going to cost very much, and if you're building racks, that means white space. So come be it admitted, that was part of the motivation. But more of the motivation came from my colleague Jack Brassel at HP Labs, here it is. Came from my colleague Jack Brassel at HP Labs, who pointed out that every time he wanted to do anything in networking, I'm putting it to the wrong. Is that he always has some piece of equipment he wants to plug into the rack. And for those of you that are going to the GRE workshop later in the week, there was an excellent paper out of a university in North Carolina, whose shall remain nameless, on using this to put in power systems. So what they did was they actually took an ExoGENI rack, I believe, and they shoved in some power units and controlled them from ExoGENI. So this is in fact not simply a necessity, but is also a virtue. Two big things about the only two things that you really need to understand about these racks. Actually, there's only one thing. It's just ProtoGENI, or it's just ProtoGENI with OpenFlow native. So for everyone in this room who's been using EmuLab as I have, more or less constantly for the last 10 years, it looks just like that. And the other thing is, it's this thing. And for those of you who don't know what I mean by that, well, it's coming up in the next slide or two. But let's talk about it just ProtoGENI. You see, the key thing was, the whole point of this particular rack design was that we were going for zero risk. Zero risk. Which meant it had to be something that everybody understood how to use right out of the box, one. Two, it had to be something that we know ran, and we know if it broke, we could fix it. Well, not we.
that guy who's sitting in the back trying to be Rob Ricci, that Rob Ricci could fix it. Why? Well, because he's been doing it for 10 years. Emulab's been running 24/7 for 10 years, and has been gotten beaten off by competent graduate students and incompetent industrial researchers. And if I can't break it, trust me, it's indestructible. So that's the first thing. It's completely enormous, and moreover, it's portable. Emulab, there are now, according to Rob and Lee Stoller, 60 Emulabs worldwide, not counting the 34 or 35 we're going to build on this program. Right? Most of them are largely from this. So we wanted to not invent anything new, but simply deploy stuff that everybody understood. So it's a network of proto-GENIs, baby proto-GENIs, with SEN native on their racks, namely OpenFlow. Allocation of resources with familiar tools and some new tools that you've seen demoed. For those of you who went to the InstaGENI session yesterday, you know what I'm talking about, FLAC. And for those of you who want to see a truly terrific FLAC slice setup, go and take a look at the thing that Rob put together to do this. So if you want to know, does this stuff work? Oh yeah, all the demos yesterday ran on this substrate that Rob put together here. It's an easy distribution. It's a proven ability to run many images. For those of you who don't know what I'm talking about, go to the Emulab website and do a list image IDs. And a truly stunning amount of stuff will come out. And the support model is extremely well understood. Heidi, how am I doing on time?
You have 12 minutes.
Okay, so when I say the GENI Apple II, I mean something very, very special. What made the Apple II a revolution was not that it was the first computer. There were plenty of personal computers before that, but they were all hobbyist kit, which meant that you had to basically build it yourself, and then it was a one-off, so it couldn't run software that was done for anybody else. I mean, this is obviously an exaggeration, you know, with a little bit of work you can do it. But it was fundamentally a tool not for people who wanted to use these things, but a tool for hobbies. Our goal with this, and we aren't there yet, but we're getting there, is to make this thing work out of the box. You turn it in, you turn it on, you plug it in. I should mention the other rack designers are doing the same thing. I think that, I don't see Jeff around, but I think you guys, hi Jeff, yeah, I think that this is the kind of thing the ExoGENI guys are pointing at too, with a different software base. So the idea is that you plug it in, you turn it on, and Rob will write the software and bring it up over the net. We'll bring up the software, we're going to configure it, and then Heidi will do some sort of magic to get it hooked up. Supposed to be easily deployable. At the moment, there is only one option. You can have you can get these things in any color as long as it's black. What you can't get is a 220. Well, you can't get 220 or 110 volt power because it's a pain to run your own power. The reason we did that, again, zero risk, right? We wanted to make sure that before we sent it out to a site, Rob had thoroughly tested it, brought up the images, made sure it was right. We put HPILO on each node so that the rack can be completely managed by the GENI lock, and we put in rather than putting in BP networking, we put in a WADA networking. 4 1 gig NICs per node and 21 big NICs and with the V2 line cards on the HB5406 OpenFlow switch, which is the most advanced OpenFlow switch to be. We are coming out now with the G8 rack, our next generation of ProI servers. The big difference that you will notice is that the G7 racks had a 6-core. We put a 4-core processor in the boss node in the G7. We're putting an 8-core processor in the boss node on the G8, and we're going to put 8-core, and more importantly, we're going to put the same 8-core processor on worker nodes. So instead of having a 12-core, having 12 cores in a worker, you now get 16 of the cameras. So overall, the rack will have about 80 cores in it, which gets us up to 2,500 full performance. The OpenFlow switch is unchanged. We currently delivered 8 racks: Utah, Northwestern, the GPO, Princeton, NYU, Kansas, Clemson, and Georgia Tech. And I think of these 8 racks, if I'm not mistaken, all 7, except for Kansas just arrived, are actually online and going through shakedown. I think a number of these things, Utah, Northwestern, GPO and Princeton are operational as of today. Actually, Princeton is
Not
not.
Princeton.
Yeah.
No, thanks.
So, but we used Northwestern demo this morning.
Yep.
And Rob used Utah for his tutorials. We're going to go, so we've now we had some hiccups in early deployments, and thanks to Nikki Watts, who you should all know, she's sitting right there. We've now got these things ironed out, and we're making a deployment schedule of 2 to 3 per month, and we're going to keep that up through the remainder of the year. So we're going to make our schedule of 32 in 2013. So other racks, we have 4 purchases to date outside the program. Kettering, I see the Kettering guys are here. Jim Griffin at Kentucky, the University of Idaho, and the University of Victoria have purchased them. And this one is operational, though not running the ProtoGENI stack. We still do have a special pricing deal with the U.S. public sector, except federal government. So if you're a city, state, town within the United States, we will make you such a deal on these things. The guy, Bill Burns from HP SLED, just had to leave a few minutes ago, but Shannon Champion from Matrix is here, and there are resellers in the space, so they'd be delighted to talk to you about this. So if you haven't met Shannon, he's in the back of the room, and feel free to go and talk to him. Abroad, we are working to get to, it's a one-off for these. Also, we, Matrix and Utah, are talking about building upgraded racks, either upgraded options on the racks or larger versions of the existing rack. And this is the subject of ongoing discussion, so we should be able to roll these out sometime soon. Mostly it's a matter of topology, photo of the rack, or rack diagram, which you've all seen before. The topology, the control connections all come through this baby 2460 switch. The data point connections go straight through to the racks themselves. The rack in Utah, I should really update this photo because we have a bunch more. The software architecture is, is the whole goal of ProtoGENI. I should put in the MetaCloud stuff into this talk. The whole goal of ProtoGENI is to be able to instantiate almost anything you want on top of it, including an OpenStack instance. I've tried the raw preaching Kool-Aid on this point, which is that there are a bunch of different clouds that people really want, and you should be able to instantiate them on top of them. I'd actually like to see somebody try to do a multi-site OpenStack instance on top of a network of InstaGENI racks, and in my copious free time, I might just do that. On top of these, you can instantiate on the nodes either a Planet Lab shared image or a bunch of ProtoGENI images, either exclusive or shared, running machines and stuff like that, running virtual machines and containers. The control node runs SIM hypervisor with various virtual machines in foam, flowvisor, a ProtoGENI boss node, and a ProtoGENI ops node. Controllers work through flowvisor and foam. Nick Baskin from Big Switch has the details on how that works. You can either get ProtoGENI exclusive nodes, this is the kind of thing you're familiar with in Emulab. We're also able to get Planet Lab shared nodes. This would look to you like a classic Planet Lab node. This ProtoGENI shared node runs is something you instantiate virtual machines in. Currently, at the moment, OpenVC is largely the way this is done. Are we running any Zen nodes at the moment? Rob?
Not on the racks right now.
Not on the racks right now. Ships with full support for GENI AM, support for Tom Lyman's RSpec stitching extension will have local foam flowvisor instances for open foam integration, affiliate with the ProtoGENI Clearinghouse, and then we'll switch affiliation to the GENI Clearinghouse when it comes up. And I'm going around later to talk. Rob is managing the software update process. It will rarely to date never has affected running slivers. All updates are going to be done by Rob and his team at Utah. You can make local mods, but this void reward. The testing period on we've gone through now for several racks, and we're shaking it through. I think, Heidi, once Nick is finished with it, once it's up, it takes you guys typically a day or two just to turn these things around and declare them operational. So we've now gone through this with several racks, and it's relatively quick once the things are delivered and brought up. And we're also working with the factory to make sure that Rob and his team get the configuration they need to be able to make the racks come up very, very quickly. And I think we've actually managed to iron most of that out. operations management, we still continue to provide the GMOC with visibility into current users and slices, and we've given people kill switch credentials for emergency shutdown, which to date has not been necessary, but we're still in early days and seeing use. Time, Heidi? Okay, I'm just about done. Even though I'm at a networking conference, I personally don't do these things. What happens is that I throw this at Jim Chen and Joe Mambretti from Northwestern, and Heidi, and she has a group that meets every Thursday. So the basic bottom line is, when we deliver one of these things, the network has pretty much already been set up, because Jim and Joe and Heidi are very, very good at prepping this. This Jim sent me last week. This is the current InstaGENI network, and we were able to. What will it all look like when we're done? This is what it will look like when we're done. So this is taken from Heidi's spreadsheet and turned into a Google map, which is publicly accessible if you want to play with it. And that's what the sites will look like. If there are errors, it's because I mistranscribed Heidi's spreadsheet on where they're actually going to go. There are always, this thing is dynamic and there are always changes in these things, but that's what we're going to look at. And Joe is busy interconnecting these things up to racks and other facilities all over the world in this array of diagrams that I don't even pretend to understand. However, you saw it, for those of you who came to the plenary demo today, you saw a bunch of these things, don't ask me which, in action today. And thanks very much for your time. Did I make
Questions? Yeah, you did. It's a historic occasion. Okay, great. Joel? Did you put your talk on the wiki?
It is, you've already got the slides. It's the same slide. Before I come up.
Ah, okay. I did. I'll put it on the wiki while you're talking. Sorry, I'm still doing it.
Okay.
Yeah, there's two of them. This is the overview one, right?
That's right, yeah.
Okay, it's there.
Heidi, how much time?
Oh, you have 20 minutes.
20? Oh,
Yeah.
wow. I'll go really slow. All right, so good afternoon, everyone.
All questions, all
Yeah.
questions.
Quick show of hands, how many people didn't come to the plenary this morning and then prepared to admit it in front of Mark? Okay, everybody went. Fine, okay, so I can skip through all these slides and we can get straight to questions. No, all right, maybe not, okay. So we're
Details.
Yeah.
You promised.
Yeah, there will be. Yeah, we have this in the paper. All right, so we're going to talk about the GENI rack project that we've just been working on with the guys from RENCI, and as mentioned this morning, a bunch of other people as well, guys from Nettop and also from E+. As I said, what we've been doing is working on UCS ESeries. So this is a blade center style chassis system into which you then insert various blades. That's providing all the compute capacity that we need, and then the guys from RENCI have ported their software stack to run on top of that in combination with the switch module. So we've got Nexus switches, which are then providing, depending on what you want, 10 gig or 100 gig port capability with OpenFlow. Storage coming from the guys from Nettop, scalable solution depending on, again, how much storage capacity you want. So starting from relatively small, going through to stupid size. And then the guys from E+ helping with the rack and stack, cabling, documentation for the site, all of this kind of stuff, handholding. Feet to go and do stuff. Diagram of what we're actually looking at. So with the way that the B-Series blade works is you have what's called a service manager node, and that then takes care of the various blades that you plug in. So your service manager effectively has a series of profiles. So when you plug in one of these blades, the profile is already defined. It then says, okay, I need to image this blade with the appropriate piece of software, or make it a bare metal node, or do whatever it is you need to do, set up all the connectivity. And that's effectively an XML script sitting in the back, a bunch of management UIs that sit on the front, but it makes the provisioning for the system very, very simple. In terms of the compute capacity, this is a mid-range system, so we can go up, we can go down, depends on what you want to do. But the worker node, so you have a head node, relatively lightweight CPU, lightweight in terms of amount of memory, and then the worker nodes. You can scale up in terms of the amount of memory that you want to plug into the thing, increase the amount of disk space you want on the thing. The software itself doesn't necessarily have to change on that. But the configuration that's been built right now, what's in WVNet, and is also on the development system, gives us 240 cores, and we've got 192 gigs of memory per CPU. So we've got a reasonable amount of compute capacity in there, and 16 RU, so it's not even half a rack for all of this. The bit that changes when we want to then potentially plug in for 100 gig is going to be the top of rack, the OpenFlow switch. Potentially you take out the 3064 and you replace that with a 7000 series, depending on what it is that you want to do. So when the 7000 comes on, we've got a small footprint, something called 7004, it goes up to 7009. And again, it's just a number of slots that you've got available, and you can plug in your 100 gig cards if you want, or mixes of 10 and 100. And that's then a hybrid switch, so you can have some ports that are under OpenFlow control, some ports that are regular learning switch, regular layer 2. You just define what it is that you want to do with those ports. With the rack itself, it may be that the compute is too much. You may want to start smaller. It doesn't have to be 2 of these devices. It could just be 1. You may not provision all the blades. You just choose how much you want. Equally, there may be somebody who wants to go much, much bigger, so we just increase the amount of chassis. The nice thing about this is we're not having to change much in the way of the actual network cabling. The key thing is this fabric interconnect that sits in the middle. It provides the stitching capability. So when you come along and you plug in another one of the shelves and you slot in however many blades it is that you want, all you're doing is you're connecting into the fabric. It's another couple of cables that go in, and the rest is then done. Right? The rest is all done through automated VLAN provisioning systems. So it's very, very simple to then bring additional capacity into the environment without having to go through the big rigmarole of running new cables around and figuring out where everything has to plug into. One of the key things that we have in the system is this virtual interface card. So every worker node that's in the system has this plugged in. This is what's actually giving you the throughput, the capacity. So you're getting 40 gig capacity from each worker node going up into the fabric, interconnecting out from there. And the way that this appears is effectively as individual interfaces. So if you think about this from your regular Unix machine, what you're seeing is ETH0, ETH1, ETH through to 127. Okay, and each one of those is then a case of, well, how much bandwidth do you want to be able to give to it? And using the UCS manager, you can then assign, you can hard code a certain amount of bandwidth, or you just say, okay, just share depending on the number of VLANs that you've actually got available. SRIOV capability are also in there, and just giving you the ability to put some serious amounts of throughput in there. What we were showing last night in the demo that Jonathan and Chris and the guys were putting together, and Victor as well, capacity between virtual machines that were clocking around just under 8 gig between the virtual machines themselves, which is not bad. With the management piece, this is one of the really nice system functions that the system provides for us, is you have this service manager node. So it doesn't matter whether you are plugging in 2 of these shelves or 20 of these shelves, the way you do the management is the same. It's just one interface. It just recognizes the system. You provide the appropriate profiles for it, so as it plugs in, it then goes, okay, I recognize what you are. You're a worker node. Image the thing as you wish. So then it's actually a case of extending the ExoGENI software to then be able to say, I recognize the rest of these nodes as being potential locations for hosting my virtual machines. Make sure I've got enough IP addresses, and then away you go. You can start to bring that stuff up. And this is just a regular UI. It has an XML interface as well, so if you like programming things, you can have at it. If you prefer to do point-click, you can do that kind of stuff too. And Jonathan's sitting there looking worried, because I'm pointing at him right now. So he's been through it. You can talk to him and he can tell you how painful it is. And it's very painful, isn't it?
No, I learned UCS Manager in afternoon.
Yeah.
And we deploy XCAT, both bare metal nodes and OpenStack worker nodes. ExoGENI nodes are all deployed via XCAT, and XCAT has a special plugin for UCS Gear that speaks to the RESTful API that UCS Manager provides. So basically, in XCAT's database that has the nodes list, I just put new node name, new position in UCS, and the position is annotated with blade chassis / blade, basically. So, chassis 1, blade 2 is node this, and then I can deploy XCAT to it.
Okay. More architecture. I don't like the slide. Okay, I'm saying it right now. Don't like the slide. We've got a load of work that's going on inside of Cisco. You may have seen some of the blurb. They've been talking more about it at MPLS World Congress this week around open network environments. So OpenFlow is just one part of that. There are other things like path computation elements that are coming in here as well. Something called 1PK in terms of an API that's being put into not just network nodes and devices, but also storage capabilities as well. So providing a northbound API that applications can be programmed to. So it's not a case of writing applications and you compile and you're running binaries on network nodes. This is a case of you write your applications, they're running on your laptop, they're running on your server, they're running wherever you want to do it. Some people have done some demos, they're running it on their phone. And it's talking to the devices and providing a series of APIs with the idea, of course, not now, but in the future when everything has been solved and world hunger has been eradicated, is everything will just work with this wonderful set of APIs, eventually. All right, so ExoGENI software stack, I'm not going to go into this too much because already Chris has been up and talking about that. We're taking the same stack. So if you've seen it before, if you understand how the thing is operating, it's exactly the same. We just have that stack, and the guys have done this job of lifting that up, taking it over to another hardware set and deploying that. But it's the same UI that you have, the same Flux interfaces you may have seen before, you're used to writing. That's all there, all up and running and working. So a stack that I pinched from their slides, so RENCI guys, one of yours. So this is just the software stack that's sitting there right now. As Jonathan just mentioned, the XCAT that's sitting there, the Nox and the Flow Visor that's sitting there, that's communicating through, doing the OpenFlow pieces for us. And then on top of that, we have the appropriate pieces, the network extensions that the guys have written. What we'll look at doing over time is being able to add in things like 1PK capabilities into that environment as well. So again, it's another set of interfaces that are potentially available. But right now, as I said, it's a case of let's build something, let's make it work, and we'll refine it over time. Let's get something out there, people can work with it, and start experimenting and developing from Just some words about the Nettop stuff. So Cisco's got a relationship with Nettop. If you've come across these things called flex pods, we already have a development relationship with these guys. So this just plumbs in and provides the various disk mounts that we need, where we have disk storage capability. There's on-blade disk storage, and then a much larger capacity sitting on these the FAS storage. So the unit that we've got at the moment is a 2240, but the guys at WVNet, I think, are going for something like a 6200 series because they want some massive amount of storage in there. So the Nettop guys, Bob Burwell's the guy who works with the higher education sector for Nettop. Very happy to talk to you. Got a couple of people, Brennan Taylor and Van Flowers, who work with a number of universities and universities, community colleges. Very happy to talk to you about what the right kind of size and scale is, which one of the various solutions that they have available. And then will be suitable for whatever it is that you want to try and do. So the way that this thing's literally working is pick what you need. You want large, you want small, something in between. You don't necessarily know where you want to start. So it may be a case of, I want the Ferrari, but I don't know how to drive yet. I'll learn how to drive, but I like the Ferrari, okay. Or you might just want the minivan. It depends on what it is you want to do. Just a case of picking the appropriate components. The software stack is exactly the same. Do you need 100 gig? Some people do, some people don't. They may want more slot density. 3064 is a small entry-level overflow switch, but it's fixed capacity, so it may not be what's suitable for you. That's fine. Just plug in the appropriate piece, and then we'll build the rest around it. And then obviously the Nettop FAS storage piece, again, depending on what it is that you want to go to. The 62000 series goes to silly numbers of petabytes, I think, that they'll support. So for all those large amounts of videos that you have that you need stored somewhere, I'm sure they'll sell you a lovely library where you can keep all your files, and many, many more of this. The account teams, probably most of you have Cisco account teams, but you might not even know. You may work through partners, but the account teams, so Ty, who's standing at the back there, so he can wave. Ty and Sergey, working in the higher education sector, can help you find them. Or there's an email alias, geniracks@cisco.com, and we'll help get you in contact with the account team and can then work with you to figure out what kind of configuration you need, sort out the quotes for you, etc. As I said, Bob at Nettop, he's the primary interface for higher education sector, and also Andy Heermann from E+. So if you want to talk to them about, okay, we want to try and do one of these installations, talk us through what the kinds of services that they actually offer, because not everybody, I was saying this morning, not everybody's got lots of people from campus IT who are prepared to pile in there and do it all for them. In some cases, it's useful to have somebody else come along and do the drudge work of labeling all the cables, do the nice little cable ties, putting nice little clips around them, putting it all away nicely. Or some people just like to have a mess. I mean, it's fine. We know the cable's in there somewhere. Somewhere. That's all I had. Questions, comments? Stunned silence. Good, we like stunned silence. Stunned silence is good. All right. Thank you.
Rajesh? Oh, I do have it. So hang on. Maybe you got stuck in the Raytheon filter.
Yeah.
Hi, my name is Narayanan. I'm in the office of the CTO at Dell. So we're going to present an update on the Dell GENI rack that we are doing with Clemson. So I think this is going to be a little bit different. We just got started a few months back, so I think we have gained a lot of momentum in our integration for GENI racks. You won't probably get as many details. I'll probably have to defer to some of colleagues at Clemson to come up if there are any questions. But also kind of giving a view as to what potentially the GENI rack could look like, maybe over a few generations. I think that is something we have given some thought to as to what are the capabilities that we can have, and not just kind of viewing the GENI rack as something to do infrastructure, but also as something to do application development, really looking at it as an innovation framework. So you just talked about flipped bullet points. So we've been participating at least in GENI and attending GENI for a couple of years now. We did a demo at the GEC16 late last year, and also yesterday at the Application Innovation Framework. We did it yesterday as well. Some of you may have seen. On the rack, we are working with Clemson. We have participated in some of the plug fests at InstaGENI. So it's all based on shipping hardware. So this is not like experimental beta code. It's on Dell proper systems. We are working with, of course, with Clemson, and also what we're looking at is we have integrated OpenStack and BBS, the RAM software on it. So what does the rack look like? So what we have is a top of the rack switch, which is 410, the S4810. So it's Dell 410 S4810. It's a 48 port 10 gig switch with 4 40 gig ports for uplink, or if you want to break out into multiple 10 gig ports, you can do that as well. We have about 5 to 6 R620 servers. So the configuration of the server is still kind of in flux, in the sense that we can go either small, either R620s or R720s, depending upon what the requirement would be, whoever would want it. But starting with this configuration, at least to get ourselves tested and kind of getting off the block. For the management switch, we have a power connect that's either a 7048 or a 7024, which is basically a 24 port or a 48 port 1 gig switch. So that's what we are looking at. So we have a picture of the track that we are actually testing and integrating at Clemson. I also know that the folks from BBN actually came to Clemson, did some integration work on the GRAM software, and so in terms of the software, that's what we have. We have done some GRAM integration, server provisioning for GRAM for virtual hosts, as well as integrating GRAM so that it can configure OpenStack's the NOVA protocol. With regards to the federation, it's basically standard GPO procedure, and I believe what we have done integration in terms of putting it up in Clemson's network using the specific VLANs 300, 500, and to test it out in actual GENI network. Those would be some of the VLANs that we could actually go integrate into. So that would be it's fairly straightforward. Just kind of getting us off the block, basically providing a base configuration. Any corrections, or Casey or any questions so far, please. So Kerr from Clemson did most of the work, and with support from Casey and also from BBN in terms of integration. Any questions so far? Just straight. So what's the some unique aspects of the S4810? There's one thing that kind of stands out, at least we feel, as each of these S4810 open flow switch can be, it can be divided into multiple open flow virtual switches. So it could be either port based or port and VLAN based. So you can think about, I won't call it replacing the FlowWizer functionality, but kind of augmenting some of the FlowWizer functionality. Say you didn't want to manage your open flow switch with FlowWizer, you can actually use these virtual open flow switches, and each of these instances can actually connect to a separate controller. So that actually gives a lot more capability. So to a degree, we are kind of assuming that the rack's there and we have the capability. Now, how do we actually use some of the capabilities of the infrastructure that we're building and connecting and providing as much software controls to it? So essentially, maximizing the SDN opportunity here. So this is something that it's not a Dell product roadmap. So this is just like a vision as to where the GENI rack can go. Starting from where we had started, because the RFP came out in early 2010, and BS vendors are just kind of getting our act together to shape our at least where some of us. But there is a potential where I think it's well understood that we can do network virtualization and the capabilities of that to do experimentation, but we also need to kind of move beyond just purely for experimentation, but also for innovation to be able to build new applications as well on the GENI infrastructure. So the first, and another kind of I would say motivation for us to be thinking about this was we started working with Clemson a few months back, early last year, or rather late last year. But then we also had inquiries from many other researchers and universities as well, saying that hey, we would like to contribute. But the thing is that to get off the block, there you can't have too many of those partnerships, at least on the first version. So that kind of got us thinking as to let's use this as an opportunity and kind of create like a rack that is being developed in terms of a rack roadmap and basically getting ideas from various universities in terms of development. So version 1.0 is something what we are working with Clemson, and hopefully we should have that soon. Now again, soon is a very it's a variable, so I won't commit to the actual date, but I think we are making some pretty good progress. So the some work that which we did last year was on this concept of the split data plane that some of you may be familiar with, which is basically deeply programmable open flow switches that marries both switches, switching ASICs with NPU, and that is something that we envisage kind of integrating into the management plane and being able to use OpenFlow to kind of call upon some of those deprogrammable NPU there. I put in SDN-enabled storage, but then after seeing the ExoGENI, the deliverable storage is probably not the, it's already available. You can question as to why is it kind of way off. But there are things that we are working on with regards to exposing the capabilities of the ASIC. I like to put SDN as a way to expose direct capabilities of the ASIC as opposed to writing just apps from the controller. Because today, if you just look at what merchant silicon can provide you, to a degree, I think it's kind. You can imagine it to be policy-based routing, right? So that's all you are doing from the controller. But there are a lot of things that layer 2, layer 3 scalabilities are some of the things that we are looking at. One of the things that another demo that we are looking at into or other in the works is some of these DCB primitives, PFC and ETS, condition notification. Those are primitives in the ASIC itself. And none of the most protocols end up using that for things like lossless Ethernet. If you had the capability to have those primitives directly be exposed to controller, a lot more possibilities. You don't want to call it DCB, but then you almost call it like another enhanced level of quality of service. Imagine QoS with losslessness. Takes you to a completely different level. So that is the capability that we can actually expose in terms of capabilities. And I think I'll kind of take a page from the previous talk. Okay, if all of this comes together, then you really have like a grand box or a grand switch, which is very deeply programmable, very solid in terms of what we can do. And I think we can create a lot of applications around it. Give me time.
You still have 10 minutes.
Okay, great. Oh, I'm supposed to remove that. Okay, so since this is going to be a GENI rack developed by all of us, we're calling it Genius. So that was my team. So this, just to kind of introduce some of the concepts on the split data plane, I think what is that we would be providing as some of the additional resources as part of the rack itself. This is, to a degree I call myself.
Can I, sorry, before you get into this part,
Sure.
you might have said this, but I didn't get it. On the roadmap, I know it's not a corporate roadmap or commitment or anything, but what was the approximate time frame you were thinking?
Yeah, so again, as we start enabling these features into the top of the rack switch, those would be, one is doing SDN for the purpose for us to build, improve our solutions that we're building. But at the same time, we are all using same merchant silicon, right? It's not as if we are building our own silicon. So we are working with the resources given by the silicon to us. So if you're going to be using certain resources within silicon to create our solution, I think it's apt for us to make some of those capabilities available directly via OpenFlow or OpenFlow extensions, so that they can be controlled directly.
So the hooks for what you would like to do are already there, and if there's
the capabilities are there. So as we cannot start building the hooks, I think at least my goal would be to start exposing them in a more open manner as opposed to just kind of keeping it proprietary, because that's what network protocols do anyway. Yes.
So you need to hear from people if they want to make this happen.
If they want
on a particular time frame.
But given that there's a lot of things to accomplish, we just can't do it on just with Clemson, right? just one collaboration. But I think it needs to be a community collaboration as to how we can actually engage a larger audience.
Thank you.
Any questions so far? So this was a research work that we did last year, and I called myself an accidental researcher because of SDN. And what happened was, started looking at exactly what is the true nature of SDN and how people were using it. And I think the conclusion that we came to was that all flows are not created equal. And the thing is that today, these are the resources that you have on merchant silicon today. You have layer 2, you have layer 3, and you have some ACLs. So you get to destination MAC address, destination IP address, you get that with your layer 2, layer 3. But then you're doing a whole bunch of stuff with the ACLs. So if you think about what today's existing merchant silicon is, and then you may want to do some granular processing where you want to do things like encryption, decryption. But most of the resources in merchant silicon are actually used for fabric, are used for base switching, and that's where L2, L3 gets you. I think there's been a lot of hype with, trying to use OpenFlow with the limitations of ACL and trying to do switching, which was not why ACLs were built. ACLs were built because you are selecting the traffic, and this is what we call microflows. You're selecting some traffic which is a percentage of the overall traffic through the switch, and you're using it for the purpose of doing some encryption. You want to basically redirect it to an appliance. It's basically hairpinning. So this was great that we have the capability with SDN to show a lot of policy-based routing and deep capability with ACLs. It will not scale, and I think that was some of the scalability discussions and frustrations that we had. It's really about the expectations of the switch, but it was not designed for the OpenFlow protocol as such. So given that this is really the use case in networks today, what we did was we came up with this concept of split data plane, where you have a switch and we have a module that basically does granular flows. And the interesting thing that we looked at was we have an OpenFlow agent on both the switch as well as the module. So this module is a multi-core NPU from Cavium, and the SDN controller manages both the switch and the module as if they are independent entities. You do want a little bit of integration because you do not want to lose the incoming port information. Otherwise, that's what happens between one switch to another. You actually lose the incoming port information from the previous switch. So there is some high gig integration, for example, in case of Broadcom that we would do. So if you have some traffic that is going through the switch and you decide that you are interested in traffic going to a particular web server, you can identify the traffic and you can send it to the module. And in the module now you can install a very large number of applications that is interested in this, and what we call as flow bursting. While on the merchant silicon chipset, you may get maybe 4K ACLs maximum. We've installed about 60,000 ACLs, basically full deprogrammable flow matches, up to 60K is what we've tested. So this was again published as part, and we published at the European workshop in SDN. Of course, this was work that kind of, so what does it look like? So you have a switch. Again, this was the Power Connect 7024 or 7048. This is what it kind of ties back to what we propose we'll be using the GENI rack, where you have open flow both on the main switch as well as on this caveat module. So a little bit on the innovation framework. So we kind of went a little bit further and said that, okay, today's the SDN architecture looks like an OSI model. You have applications, you have control, and you have data. And I think this is a little limited because software-defined networking is all about software, and now it's kind of stuck in an OSI model. So how do we kind of turn this into an SOA architecture, Web 2.0, where if we have been witness to Web 2.0, we know the kind of applications that got built. So we kind of took the apps out of the picture, and we introduced something called the statistics plane, where we have a stats module on the data plane that is asynchronously it is pulling stats from the data plane. So what the stats module does is it basically goes to OpenFlow OBS. It just pulls out all the flow stats asynchronously. There's no application visibility there. There's no selection criteria. There are stats available. I'm just going to pull it out and I'm going to externalize it and store it in a time series database. So what now happens is each of this control plane, data plane, and stats plane actually becomes services in a service-oriented architecture. Now you can have application that is kind of lying on it flat, as opposed to a stacked architecture. You get a SOA. Again, we're not trying to get around OpenFlow. You still have between the control plane, data plane, you still have OpenFlow. Between the control plane and the apps layer, it is still northbound APIs. But now we can have all these modules that we are adding on the data plane itself. You can have hooks. For example, we have things like encryption, compression. All these engines require certain parameters, and you can have those parameters directly be controlled by the application layer now. So, and the stats plane is again an externalized time series database. So we have this framework, and we are starting to create some university engagement around this, working with a few more universities. And we are basically calling it a fully open framework, where you have open control plane is floodlight. We have this Dell switch with a Cavium module with the Linux on it, where you can dynamically insert these modules into the packet processing pipeline without rebooting the switch. So if you want something like like an ICMP proxy, you can input it in. You can download it. You can download the application directly into the switch. And stats plane, again, it's open. There's a project called Open Time Series Database, OpenTSDB. This is from a company called StumbleUpon. I'm sure we all heard about it. The stats plane, gotta give credit. If you've seen Boundary.com and seen their presentation, you think was inspired by what Boundary is doing. So the extensively framework, you may ask a question, okay, how does it tie to OpenFlow and OpenFlow extensions? In fact, we have created an architecture where you have extensibility without extensions, where these extensions become a path property. Because now what we have, for example, we showed in the demo yesterday, we have an ICMP module which is on the data plane. When the ICMP module is loaded, it basically comes up as a virtual interface, and we tell OBS to go manage that interface. Now what happens is, an interface in the traditional sense leads you to a host or it leads you to a network. What we have done is, an interface leads you to a network function. It leads you to an encryption function. It leads to a compression function. Now, all these extensions are no longer, extensions, but really path computation problem. Statistics plane, OpenTSDB. This was the demo poster that you saw yesterday, and some of the demo stuff. This is the ICP proxy. We're working with University of Houston, Denise, and Levin, and again, basically creating a big collaborative environment for SDN innovation. That's really the key. Any questions?
Everybody must be tired. This doesn't usually happen.
The 7-second rule. Right?
Okay. Peter?
I'm going to talk a little bit about the issues that campuses go through. So you think about campuses attached to regional optical networks attached to the backbones, and they have to do the similar thing on the other side. And so there's some issues that campuses face when it comes to provisioning VLANs, provisioning bandwidth at various speeds. And that's what we're going to talk a little bit about here. I stole this diagram from the solicitation board that's out because I think it's important that we all recognize, well, what are we all doing on this project? Just to sort of help get this flow working as smoothly as possible for the experimenters. And to also point out that the layers 2 and 3 are used in conjunction to make GENI work. So we need to have the connections at both layers in the stack. So on campuses, they publicize the resources that they're making available, and they set the policies that are associated with them. And they have their own access mechanisms that are there, that are publicized for people who want to begin to list and request those services. So it's fairly decentralized, and as is the resources and the management of the networking capabilities that are there on campus. So what we're doing is allowing the researchers and experimenters to do their own authentication, create the slices across the substrate, and run the experimental code on the machines. And there's this other effort going on campuses which has to do with science DMZs and condos initiatives that we've been hearing a fair amount about as well. So the question is, well, how can those efforts complement each other and work together well? So this science DMZ, in a nutshell, is basically to separate the production networking for the campus, their operations they're running, their authentication systems, their office back systems, and separate from the scientific resources that they want to put up to be able to get good throughput through and low latency flows on their data resources. So what I want to do in this little picture is to kind of depict some of that. And this is morphed from what the ESnet folks have put out. So I've kind of done some modifications on this as well. But it shows the GENI resources, the rack, the aggregate, as essentially as a standalone set of resources on a campus. The campus decides what's there and how they're going to allow the access in. The open flow controller that's part of that is also used to set up policy constraints on the use of the resources. And most of the campuses have their own data resources that are set up. And the blue paths are meant to show those higher performance flows, with the red lines also being the links that go back to the campus production systems and network. And so you have the red link coming out of the GENI rack, which supports the control plane, passing through the campus network border router and switch to get out to I2, NLR, and the public internet, as well as to reach the GENI clearinghouse for authentication and credentials to be established in conjunction to getting to ExoGENI and InstaGENI sources that are available too. So you have these layers, the campus, the RON, and the national backbones, all of which have to play a role in creating the VLANs, in figuring out the provisioning of the layer 2 flows, and handling the segregation between the production and the science flows as well. So in a multi-aggregate topology, you have the layer 3 control channel connected to the clearinghouse for the authentication and authorization credentials that are passed on. The layer 2 data plane connections are typically used to set up slices with the aggregates. That can include, elements of computation and storage and bandwidth. And you have the campus network engineers that handle the local policy issues associated with the use of those resources. Some of that can be configured through the OpenFlow switch, some of it through the border routers and switches, and mapped accordingly. So the experimenter uses all those resources and tools and expresses and builds and analyzes their results. And all of those pieces and components have to be interrelated and integrated and work well together. So it gets a little tricky, though, when we think about how these VLAN options are negotiated. As Tom Lehman presented yesterday, too, in his stitching talk, there's a handful of ways to do this. The parties can basically get on the phone or on email or have a range that they're working on to establish those address spaces for the VLAN flows. They can use QMQ tunneling to essentially wrap frames together and to do some dynamic version of provisioning as well. And so there's tools out there, and yet, as we heard at the campus CCNIE meeting in NSF in early January, there's not a lot of interest in campuses supporting provisioning from the campus going out, at least not yet, not at this point. Now, some of that maybe can change as the stitching tools and other kinds of capabilities move forward, but we're not there yet. So that we have this series of options, but we also have people voting with their feet. And the empirical, what we're learning and understanding so far is that most everyone is establishing a kind of static range for their campus and doing some selection and assignment. Sometimes even leaving VLANs set up between various points too is a way to minimize the kind of human time for all that. So the other option, oops, losing myself, that we heard spoken about as well has to do with expanding from just a standalone GENI set of resources to be able to use those resources on a campus to bring in other domain science activities that are happening on that campus and to share those through the GENI infrastructure and to have that as part of the experimenter resources that are available. So campuses can add incrementally or in large amounts of resources to make available to the community under the same sets of policy and administrative controls that they feel comfortable with. And so the question becomes then too, the other example is as was heard spoken yesterday, and I think a little bit maybe today, the DINES project that was supported by NSF is available on a number of campuses for the high energy physics community to analyze the data from CERN on the LHC project. And that does include, that rack configuration does include OSCARs, the dynamic provision capability. But it is, so far, our understanding is there's very little use of that beyond the DINES rack itself. It's not expanding out to include GENI, it's not expanding out to other campus resources as yet. So there's these pieces of activity that are happening. They haven't coalesced, they haven't bubbled up together. So we need to understand better how some of the tools can be integrated and making an easier environment for experimenters on campuses to work together. So I think this slide is essentially saying what the previous one did. Everything works through the GENI AM Aggregate Manager API v3 to both authorize and request and check status of resources. There's also the OpenFlow capability that's becoming common, and a lot of people are incorporating all of those issues. The thing that is unclear, though, some vendors are supporting V1. Some people like to use the later versions of 1.2 or .3, and so there's some incompatibilities that have to be worked out there too. It's nice to hear what Chris Heermann was talking about with their use of the hybrid mode, which is another capability that I think helps provide a capability for campuses to trust having single switches too, to handle some of their production traffic and some of the experimental traffic. But not all vendors have that functionality up to a level where people have a lot of confidence in it yet. So the options. You can link directly to one or more pre-provisioned core VLANs without using any campus OpenFlow resources. A simple option for experiments that don't need OpenFlow campus resources, merely want to access the GENI mesoscale environment itself. You can use OpenFlow to link one or more pre-provisioned core VLANs via cross-connect cables that trunks campus OpenFlow VLAN onto the core VLANs. This too is a fairly simple option for experiments that want to use the OpenFlow campus resources and the existing mesoscale resources. And you can use OpenFlow to link any of those core VLANs by using OpenFlow to configure the switch and to perform some level of VLAN translation. It's a more complicated option for experiments that want to use OpenFlow, but it is possible to go forward with that. And so even though we have ION from Internet 2's offering that uses Oscars and can handle the dynamic provisioning, we're still left with very few regional networks that will do that translation and support the dynamic capability, and even fewer campuses themselves that will be doing that. I think that, as we go forward and anticipate this, we need better granularity in some of the tools. Not so much for the VLAN addressing part of it, but for the bandwidth. To say, allow experimenters to say that for certain kinds of experiments that they want to conduct, they would like to be able to specify the bandwidth in the past to look at not only throughput but latency issues. And so we need to have some of the work going on that looks at some of those knobs and twists as well. Because it's right now we have topology service, we have Oscars, we have the perf sonar capabilities within that incorporates Oscars, and there's the UNIS set of tools too that is being refined at Indiana University through Martin Swaney's group of students. So all of those things are good contributions. The question is, is there a suite that provides most of that functionality by design up front that we could work towards supporting? One of the things that I always get confused by is there's so many tools that we have available in GENI. It's very difficult, I think, for experimenters to look at that, become accustomed to going through a portal or starting to initiate an experiment, and understand how to streamline it for what they need to do. And so we heard a lot of those themes expressed here the last couple of days, and I think that's going to be the big challenge for us as we go forward over the next several months here. So stitching is, I think, an important part. Although again, it's a useful tool and a good set of functionality. Tom and GENI, Tom Lehman and GENI have done a wonderful job in terms of coding that, getting it up and running, and I hope everyone had a chance to take a look at it last night, read some of the papers and architecture documents that they have associated with it. And yet it's going to have sort of limited use initially. In terms of, again, the same layers. Tom is correcting me and saying, well, okay, it doesn't matter whether VLAN translation happens or not with stitching. What's important is the campuses can still establish their own set of VLAN range numbers and have the capability of stitching supply that, use one of those from that range. And that's all to the good. So, it's a good piece of work. They've done solid coding. on a number of areas for GENI in the past, and we expect that to go forward. And it's all open source code. That's a real good part too for everyone. So this gives you the sort of sense of just a picture of how the stitching works. It's really meant to understand how you can go from one aggregate to another aggregate where you may have intermediate networks that are not doing anything other than providing transport through. Sorry, I don't know what I did or didn't do. And so that's what the gray areas are meant to depict. That you're going from the aggregate on the left to one of the ones on the right, you may have to pass through some of these networks. So you need to understand the topology that's there and how you can adequately list the kind of resources that you need to pass through those separate autonomous systems or autonomous domains. So that's what I wanted to kind of highlight. Comments, questions?
The next session is audience participation. So you all need to wake up. I'd like to see a show of hands. How many people have OpenFlow switches or GENI racks or some other type of SDN in their campus or their company or their nonprofit that
whatever
sends data
you represent.
That sends data off of your campus right now? Raise your hand if you have it.
I don't know if I should raise my hand or not.
Okay, good, good. So almost half the room. So we really want to get input from you here because you may not realize it, but you're already doing SDN peering. And if you don't realize it, this is the session where we're going to discuss it and why you should be scared. But we think it's a great opportunity in GENI, and we think a lot of these things that we talk about in general that are, oh, the experimenters are going to have wonderful abilities to knit together new services and networks and virtual machines together. We're always assuming that that stuff is deployed onto campuses and that there are willing and helpful participants on the campuses who own that stuff, and especially the campus resources. And those people need to understand how that's being made available to other people and who those people are. So in the next session, there's going to be some detailed discussions about stitching and a little more insight into the clearinghouse and the portal and the monitoring that are little different pieces of answering that question. So if you're interested in that stuff, please come to the next session, even though it's called Operations and Monitoring, which I know normally makes people fall asleep. It's going to be a good audience participation session too. I'm not going to show my slides because I think people are too tired. And Russ Clark from Georgia Tech is going to help talk about SDN's peering in the campus environment and what you guys think you're going to need for the next steps of GENI. Because unlike other discussions where you might be hearing SDN peering discussed as a kind of an academic topic, in GENI we've done it already with individuals talking to each other and making it really hard to make these connections with static VLANs, and basically that's been the thing that stops true SDN peering from happening, is that it takes so long and it involves humans. And we're about to solve some of those problems, so we want to make sure that we've gotten your requirements and your ideas in as campuses for how you're going to want to be able to deal with that. And so the rest of this is a little bit of orientation from Russ, who's already been dealing with it and has some partnerships going on in Georgia Tech, and then hopefully good ideas or complaints or comments or whatever from you guys. So,
Yeah, so you,
do you want to use your slides, or do you want to do the same thing?
Yeah, let's do the same thing. I think it'll be
Okay.
more fun. All right, so we did a, do we need microphones, or how, do we have anyone online? Do we need microphones for that? Otherwise,
Is there anyone online?
Otherwise, let's just.
Yeah, okay. I
Okay.
think there's nobody.
So we did a session at Joint Techs back in January about this, and so working Ron Hutchins and Nick Feemster from Georgia Tech and a few other folks were involved from Google and from Maryland, and Dave from Maryland, and then we had about 20 or more folks in the room, from different backgrounds. How many were any of you? Some of you were there. I don't know. 10. Yeah. Yes. One. So okay. So not too much overlap, but for me, one of the takeaways from that discussion was that peering is, in some sense, a really loaded word that maybe we need to come up with a different term for this discussion. Okay. The first thing is, we're not talking about let's redefine BGP for the next generation of the internet. Let's decide, in this work we're going to come up with the replacement for BGP. And I think that's that's a great goal. Someone should do that. But I don't think that's what we're trying to do here. I don't think that's the problem we're trying to solve. I think we have much more solvable and real problems that we can approach, in this community. And so, when we say the word peering, and we've sort of found this in talking, we've been going out to, potential partners, commercial partners, to talk to about working in this space. And when we talk to folks like Google, or when we talk to content providers like Netflix and folks, or operators like Comcast, they're all interested in working with us on SDN, and we should do some work together. And then when we say the peering word, they get all up in arms and they say, ooh, that's going to involve lawyers. And we can't possibly peer with you because that's way too loaded a term for us, right? As a internet provider, we can get sued if we make peering agreements with other people that are favorable versus the ones we have, for instance, right? And so they don't like the word, right? So I think part of what we want to do is redefine it, come up with a new word even, and let's talk about what we really mean. So we're talking about, solving this problem of, stitching is in this space of, we've built up these GENI campuses and backbones and regionals, and now we want to look at, the solicitation 4 is all about looking at, the future and sustainability of this thing. In order for that to happen, we're going to need lots of other partners to help make it happen. We're going to need corporate partners to make it happen, people that want to make money out of the results of our work. And in order to do that, we need to start peering with them and exchanging some data with them and allowing them to participate in these research, so that the demo that we do at the next GEC can have, Netflix content or Google or whatever. And so I think, looking at things like, the cloud space, some of the questions that people want to talk about when we finally get into this, we're looking at the private cloud versus the public cloud, and how do we bring those two together without all the fear people have about opening my corporate data to the public internet. So we don't want to do the public internet for that. We want to do something different. We want to do something maybe with SDN, something maybe that we can experiment with on GENI. So those, I think, sort of setting the stage. So don't think BGP, don't think traditional peering. Think, how do I take my GENI project, how do I take my GENI-enabled campus and connect it to other interesting things on a project-by-project basis, not on a, I'm going to turn over my campus peering to GENI. Does that make sense? So, what kind of projects are you working on? What are some real problems I guess, that we want to solve in this space.
So those of you who raised your hands, what did you have to know about the endpoint that you were exchanging data with, or the multiple endpoints that you were exchanging data with, in order to say, okay, I'm going to authorize that VLAN, or I'm going to authorize that OpenFlow, Flow, or MPLS, or whatever else it was that you were using to allow for software-defined network on and off your campus? How many people did it because you knew the guy at the end personally?
Start with the question.
Yeah.
The early model of running an OpenFlow experiment across is we actually will use the GENI core VLAN, connect to no VLANs.
Right. The thing that was painfully and manually set up.
End to end.
Yeah.
So is that model changed right now? That's why we have this discussion. That is actually we don't know the other end, and then now we.
Well, so that's one of the questions is if stitching was totally dynamic and could use any VLANs that existed to connect to anybody else, then potentially, right, you wouldn't know that because it's already VLAN 3715, there's only a certain number of connections that have been set up painfully by Tim and Internet2 and NLR and each of the campuses. So you wouldn't know the universe of people who might connect to that. So if the VLAN number by itself is not enough to identify who you're talking to, which in that kind of a stitching world it won't be, what else do you need to know to say, yeah, okay, that flow is still okay? And I'm just using VLAN as an example. I'm not trying to say that everything is done with VLANs, but everything that we did manually was done with VLANs, so that's the easiest next step. So yeah, it's because we're making it more dynamic and having more possibilities. We're not saying that we're going to go from where we are now to, you know, you could stitch to anywhere, and we don't think people want to do that. But if anybody does, raise your hand.
So this discussion is more from the campus perspective, not from an end user or researcher perspective.
Right. We're assuming that each campus is supporting the researcher and deciding, yes, we want to do that, as opposed to the researcher can.
Does the researcher know they want to come?
I don't know. What do you think?
I mean, Russ, in your example, you said if you want to connect to Google content, are you thinking about a researcher provision and experiment saying, I want to have this piece of campus, this piece of regional, and eventually I want to get Google? And do you expect that researcher to specify specific requirement on the end-to-end path, or do you expect the researcher just have to know up to a certain point, say to the boundary of regional, and then beyond the regional, it's actually controlled by the region, not controlled by Google? So that seems to me two very different scenarios to think about at what point this kind of decision needs to come up, and researchers have to work with the campus to describe what they want.
So, yeah, I mean, I think in the examples I've seen, there's some specific project that they want to do, that a researcher wants to do with another entity, whether it's commercial or a research lab or something, where they want to get out of their current policy limitations. They want to create a set of new policy rules, define their own policy rules basically on how our island is going to connect to their island, and it's not going to be constrained by what we can do currently with BGP and our current peering relationships, right? So whether it's a QoS that they're defining, or some type of control over the actual path, that kind of thing. Probably the researcher isn't going to specify more. Isn't coming with more than that, right? I want a special relationship between these two entities. Is essentially what they're saying, right? And figure out how to make that happen, right? Short of buying a lease line, right? Figure out how to make that happen. And that's probably the starting point, at least for the examples I've seen. Does that make sense? it's probably that. I can't think of other any examples I've seen that don't sort of boil down to that. Now, I mean, there's different reasons they might want to do that, but ultimately that's kind of what,
Right, so the scenario you're talking about is really, in the past, we designed experiment requirements based on a 10-trench topology specification. From now on, we are thinking about a model where we control a certain part of the network path, and then beyond a certain path, there's an interface. And we're discussing about how the campus enforce that interface interaction with the other providers.
Mm-hmm. Yep. So we have a new GENI rack. I'm going to pick on you. We have a new GENI rack owner here from Kettering who hasn't had the advantage of even being able to use his rack yet. But you were kind of nodding your head, so I'm picking on you. What is it that you need to know about the places that you want to connect to with that new rack and do stuff with in order to authorize open flow connections out of it?
Well, we got a couple, but the one I'm most concerned with at the moment is I've got a local hospital who probably has their own ISP provider. We have Merit, which is our ISP provider. I want to communicate with the hospital with an open flow controller, and then maybe another entity that may be on the hospital's ISP, but maybe a separate one completely, and be able to communicate through open flow. And so, yeah, I think we're going to run into those sorts of problems. I think.
So you know it as an organization or as a set of IP addresses, or you don't know yet?
Organizations at the moment. Okay. I mean, I can get the IP addresses, but as organizations more we're looking at.
What about other people who have switches and things that go off campus besides Clemson?
Lost them all.
Yeah. What about RENCI? You'll connect to anyone, right? Yeah, yeah. Trying to find out what makes a good use case. Yeah, that's a good point. Yeah. And you'd like it to be consistent between all the places that you could get to so that you understand it. You can go to Kettering's and it looks the same as RENCI's, looks the same as BBN's, if you're talking about a certain kind of resource. Yeah.
And today the advertisement is you put your RSpec on the wiki and people find it, and then that's how they know what resources you have available. Right? I mean, that's what it boils down to.
Yep.
The context, Heidi, you bring up is today we have this pair of GENI VLAN and then all the mesoskill campuses are connected to that. So it's another aspect of the discussion is who are allowed to be part of that VLAN, right? So going to the future, if we want to connect the rack to a certain organization, then it seems that you will want a VLAN stitching path that only allows specific entities to join that VLAN. Is that right? So
well, that's one way to manage it. Yeah, but so say say that there was a commercial hosting center, right? And there were actually, you know, SDN startups who wanted to do projects with universities at that hosting center. Do you have to set up, you know, completely separate VLANs to do that? Do you say it's okay for VLANs to have some endpoints in the research environment and some endpoints at that hosting center? Are there?
But that would be the natural decision, question that will be asked, right? So.
Right. I'm just trying to ask it ahead of time,
right. So,
before we break everything.
That's actually the answer, right? So we're discussing what do we need to know about SDN peering, right? What attributes do we need? And actually, that is the answer. We need to know on a project basis or resource basis, who do we want access to that resource or to that project. So we do need probably in parallel multiple different sets of VLAN switching happening at the same time, but with different clustered participation for different contexts.
Okay, so one thing saying we need to advertise what we're willing to connect to, and another thing saying we need to be able to look at what people are advertising and decide for each of those whether we want to connect.
Probably that company wouldn't want to advertise to every campus, and
right.
you only want to advertise to 5 of them.
Yeah, right. Because like as the Dell person said, they would be overwhelmed by people trying to partner with them. So,
Well, I can understand it. You know, peering. You know, traditionally peering is free exchange of traffic with equals. But in this kind of, in the Kettering example, it's not really amongst equals. It's like point-to-point kinds of relationships that would have to be developed. And so there has to be some assurance provided to the other side that it's only going to go, that communication traffic is only going to go to, you know, that hospital.
But eventually you want to scale it out.
You do, yeah.
Past just the hospital to more entities.
Right.
okay, so there's the advertising, there's the looking at what's advertised and making a decision, and then there's the how do you know once you allow a connection that what you said should be happening is actually all that's happening.
Right. The policy enforcement.
Yeah.
It's sort of like, you know, with I2's traffic too, they filter, you know, you pay your dues annually. I think this is still the case, right, Matt? I mean, because you don't allow a lot of, you know, the only people who can use your network are the people who pay to use it and have an authorization to. So there has to be some sort of filtering, I would think, similar to what Casey's saying too.
Okay, well, so we're at the end of our session. It's not an easy question to answer.
So I think what would be helpful to make a next step is to better define what we're talking
Yeah,
about. Because I'm hearing a bunch of things,
suggest.
and I don't quite know, I don't quite have traction in my mind about how to
So
approach it.
our evil secret plan was to try to get some people to volunteer to help.
Thanks, Matt.
No problem, Russ.
To help,
you host me down there while it's snowing in New York?
Yeah.
Absolutely.
So come up with some input for what you as a campus would like to do. Please, 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 at least 2 or 3 people volunteer. And we can work on that. There are other people at Internet 2 and at ESNet and out in the research community who are also working on this. And we can try to put together example use case that then everyone can tear apart and say we got it completely wrong. But so I'll let it stew for a while, and then I'll start nagging people to volunteer if I don't get enough. But if you're willing to volunteer, please let me know, and if not, I'll come hunting for you. Okay, thank you all for participating, and see you on the network. Hopefully see you at the next session.